Moving on to assignment number 21, and we're starting to get to the point that, like in the previous one, it was a multiple choice, and if you didn't really practice those, you might want to go back because that was meant to be an easier assignment. When we're multiplying polynomials, you might have binomials, you might be multiplying any number of things. So we're starting to get a little bit more difficult here. Before I start, I need to define some terms. So let's define, I'm going to skip ahead to monomial. A monomial is an expression, an exponential expression, with, and then mono means one. The reason why mono, the disease that you catch from kissing, is called mono is because you can only catch it one time. So mono means one with one term. So for example, just anything, 3t to the third. If it has one term, separated by a plus or a minus, just a single term, it's a monomial. And then obviously the other two would be binomial, an expression with two terms. For example, I guess the most common one, I don't know, 3x and then plus 10. So that's a binomial. It has two terms separated by a plus or a minus, two terms, and so I call that a binomial. And it's important to look at how many terms they have because that's going to determine the structure of what you're multiplying. You'll see that in a second. And then trinomial, an expression with three terms. Okay, and then the reason I wanted to define those first is that a polynomial could be any of these. So a polynomial could be a monomial, could be a binomial, it could be, I guess, a quadrinomial. Polynomial, an expression with any number of terms. So usually, you know, if we are doing a small number of terms, then we'll say, okay, this is a monomial or this is a binomial. And if it's some big number of terms, then we would just say, well, this is just a polynomial. It just has some huge number of terms. So for example, I don't know, like 6 different terms. So 3x to the 5th plus 4x to the 4th minus x to the 3rd plus 2x squared minus 7x plus 4. This is 1, 2, 3, 4, 5, 6 terms. And so I wouldn't keep naming these. I would just call this thing, a polynomial. And again, a trinomial would be something with 3 terms, like 3x to the 6th plus 7x minus 4. So that's got 1, 2, 3 terms. So I would call this thing a trinomial. All right, and we're going to be needing those terms because I've got different kinds of polynomials here. So for example, this is a monomial here, one term, and then it's multiplying a trinomial. And I need to see that structure, recognize that structure before I start my box method. So this is a trinomial times a 1-2 binomial. And that structure is going to determine how many terms I have to organize. All right, so let's see what I mean by that. So I've got a single term here, so the box that I make needs to have room for a single term going this way, and then it needs to have room for 3 terms going across. All right, and there we go. I've set it up so that I can put my monomial on the outside, negative 7a to the 3rd, that I'm simply distributing to all these things. But it's nice to have a box because I don't have any choice but to multiply now. So for example, when I was doing my multiplication, I might remember that I'm supposed to do 7a to the 3rd times 4a to the 3rd, the first 2 terms, but then I might forget that the 7a to the 3rd was supposed to be multiplying these 2 terms as well. And it just makes it easier. You will never forget anything if you just have a box. In other words, there's a blank in this box for everything, so hopefully you won't forget. All right, so I'm multiplying. In this case, I'm multiplying negative 7a to the third, the thing on the side, times 4a to the third, the thing on the top. Negative 7a to the third times 4a to the third. And I broke it out here so that I can bring my two coefficients, just the numbers, negative 7 and 4 together, and then the two exponents, a to the third and a to the third together. And then the two coefficients, negative 7 and times 4, negative 7 times 4, well, that's one thing. That's negative 28. And then the other one is an exponent. 3 plus 3 is 6. Now, I'm still timesing these two things. It's just that the rule of exponents is to add the two exponents when you're doing that. Okay, so that was a long-winded way of saying that when I multiply this thing times this thing, I get 7 times 4 is 28, and then 3 on the top plus 3 on the side makes 6 a's. And then, so that means that the term that goes here is negative 28a to the 6. And I won't go that slowly from now on. I'm just going to multiply. So 7 times 4 is again 28, and then 3 on the side plus 2 on the top make 5. A to the 5th. And then the last term is negative 28. I'm going to put a 1 here to remind myself there is an a there. 3 on the side plus 1 on the top make 4. And each one of these terms, a to the 6th, a to the 5th, and a to the 4th, all have a different rank, so I can't add them together. And now I'm ready to write my final answer. Negative 28 a to the 6th, negative 28 a to the 5th, and negative 28 a to the 4th. Oh no, I missed one. Which one did I miss? Negative times positive, negative times positive, negative times negative, positive. So I should have done this negative in the 4 times this negative in the 7 to make positive. All right, pause here if you're trying to keep up. So I am, when I set this up, I tried to do a couple that were similar together so that you get a sense that everything is making sense. And then we'll start doing more difficult stuff as we go. So the monomial, I put room for the monomial to go on the side, and then this trinomial I'm going to put on the top, which is why I left room for 3 spots. And negative 6p. Please do always bring the sign with it, so the negative 6p, all that stuff goes here. And then negative 3 times 7 is negative 21. There's 1p here and 4 p's there to make a total of 5. 6 times negative 3, let me try a different color, is negative 18. And 1 here and 3 here make 4. And then lastly, negative 3 times negative 6 is positive 18. 1 here and 1 here is 1 from the top plus 1 from the side make 2. And those are all of different rank. Negative 21p to the 5th minus 18p to the 4th plus 18p to the 2nd. All right, pause here if you're keeping up. In the previous two problems, we've only had a monomial. In the previous two problems, we could have done this with an old method. We could have done this just by distributing. 3p times 7p to the 4th, 3p times 6p to the 3rd, and 3p times negative 6p. So I just multiplied this way. But this is a problem that I wanted to do to show you how useful the box method can be to keep track of all the stuff that you're multiplying. So I need to leave room on the side for 3 terms going this way, and I need room on the top for 2 terms going that way because of this binomial. So I'm going to put my trinomial across here and my binomial down there. And so I need room for 3 going down and 2 going across. So I'm multiplying 6 different things here. So it is really starting to get useful to keep track of all the stuff that's multiplying all the other stuff. Okay, and each one of these terms are multiplying both 3r squares and 7r's. All right, so I just need to get started. I'm timesing the thing that's on the side times the thing that's on the top, and that gives me inside the box. And then when I'm done, I'm going to add all the like terms together, the terms of the same rank. 7 times 3 is 21. and 4 on the top, or 4 on the side plus 2 on the top is 6. 7 times 7 is 49. 1 on the top and 4 on the side make 5. 7 times 3 is 21 again. 3 on the side and 2 on the top make 5. 7 times 7 is 49. 3 and 1 make 4. Negative 4 times positive 3 is negative 12. 2 on the side and 2 on the top make 4 r's. Negative 4 times positive 7 is negative 28, and 2 plus 1 is 3. So I filled out my box, and on this occasion I wanted to write it out lengthwise before I looked at the diagonal, just so you could see what it looks like lengthwise, because I am just adding all of these terms together, and I need to write small. Don't write this. 21r to the 6th plus 49r to the 5th plus 21r to the 5th plus 49r to the 4th plus minus 12r to the 4th minus 28r to the 3rd. So I have a grand total of 1, 2, 3, 4, 5, 6 terms. And then if I wrote it out this way, you could then go back and say, okay, these two terms I can add together, 49 and 21, to make 70 r to the 5th. And then these two terms I can also add together. 49r to the 4th minus 12r to the 4th makes 37 r to the 4th. But I'm not going to write it out lengthwise. I'm going to go ahead and, in this method, look at the diagonals, because that's where my like terms are often. So I just wanted to show you that, to emphasize that I'm just looking for the terms that have the same rank, r to the 5th, and then adding them together. But I can do that inside the graphic organizer if I want to. Because the terms are often on the diagonal. They're right here. Here's an r to the 5th, and here's an r to the 5th. So I'm going to draw an arrow going through those two. And then 21 plus 49 makes 70 r to the 5th. And then that takes care of those two terms. And then the other two like terms are my r to the 4ths on the diagonal. Negative 12 and positive 49. That kind of covers up what I was trying to do. So negative 12 r to the 4th here, and positive 49 r to the 4th here. And when I add those together, I do get 37 r to the 4th, and that takes care of these two terms. Okay, so now I've added my like terms. I only have my remaining terms, 21 r to the 6s. So I'm done with that. 70 r to the 5ths. Okay, got that. 37 r to the 4ths. Got this. And my last term that I don't have yet is minus 28 r to the 3rd. All right, this is an r to the 5th here. All right, so you can start to tell, what I'm talking about when I say that it's important to stay organized. This really is just about organization. And I'm left with a polynomial of degree, the rank here is 6. And if you wanted to call it, I don't know, a quatrinomial, it has 4 terms to it at the end. All right, so pause here if you are following along. And then I'm on to my next problem. We're back to another binomial situation, but this time it's a binomial times a monomial. Actually, I have time. I have 1 minute. I need to hurry through this one. So I leave room for just a single term on the top, but 2 terms on the side. Uh, 5n to the 3rd and plus n squared. It seems like some people very much like putting the 1 in front. But when you're done and when you have your answers, take the 1s away because it doesn't make any sense for it to be there. 5 times 2 is negative 10. And 3 plus 3 is 6. And then negative 2 times positive 1 is negative 2n to the 2 plus 3 is 5. And so my final answer is negative 10n to the 6 minus 2n to the 5th. And I just wanted to point out to you that it doesn't matter what order they come in. There's no reason why the monomial has to be in front. You're still just distributing this times this and this times this. And the box method catches that up with you. Just leave room for a binomial here and a monomial here. All right, and we'll finish with part 2 next.